And now we go to a transistor resistor, right? I said many times, I said last time, what is a transistor? It's a transfer resistor, right? So I think this should be a typo. I should say transistor resistance, right? This is a typo, right? The resistance of transistor. If you look at this IDVG curve, wow, the resistance keep changing. I have a small resistance at the beginning and then a large resistance at the end. But as a circuit designer, what do I care? First of all, why we care about resistance? You did that in assignment 1 already, right? Remember that when you try to charge a circuit, for example, inverter, right? I try to charge it from, let's say, 0 to, let me do opposite, from VDD to 0. So what happened? My input will go from 0 to VDD, correct? So in this case, this one is open, right? So the current is going to go from here to here. This is C. And the delay, right, is related to the R, the effective R, right? But remember, for the delay, can you remind me, what is the definition of the delay? Maybe the best is to draw a graph like this. What is the definition of the delay? You just done the homework. No one?
The difference between the input and the output waves from the 50% points.
Very good, from 50% point. Right, this is 50%. So this is the delay, TPLH in this particular case, in this graph, right? So in this case, my drain, in this case, what is the VD change from where to where? VDD to half VDD. That is what care about, right? How about after half VDD? I don't care because that is not my definition. Once it changed to half VDD, I'm done. That is the delay I want to calculate. So you see that I only care about the effective resistance from VDD to VDD divided by 2. This is an example. Okay? So because of this, I'm going to define the resistance by averaging them. Okay? So the first thing is that at VDD. Okay? At VDD, what is the current? Is VDD the resistance, I should say resistance, R, I call it RVDD, equal to VDD divided by I when VD equal to VDD, right? But what is I divide, what is I at VDD divided by at VD equal to VDD? Here I just say is equal to the saturation velocity times 1 plus lambda VDD. Make sense? Where I set is the complicated equation K dash W on L, right? VGT, V mean minus V mean squared divided by 2, right? This is just that term. And then I set equal to this one. Is this okay? Is that clear? Now, if this is clear, then of course, I also want to know at VDD divided by 2, because at VDD divided by 2 is where I stop calculating the delay time. Then at that time, our VDD divided by 2 is just equal to VDD divided by 2, right? Because the voltage across the source and drain is VDD divided by 2, divided by ID set, still ID set, 1 plus lambda, but this time is VDD divided by 2. Okay. And then the equivalent resistance, because it's pretty linear, as you can see in the graph, is just half 1 plus 2. Okay. And we are not going to do the math. It's not too difficult, but you will get this. So basically, right, you won't derive this many times, but basically the equivalent resistance, you are going to calculate the delay due to a transistor is VDD divided by ID set times 1 minus 5/6 lambda VDD times 3/4. Is this okay? Sorry, my writing are not good, right? But my excuse is that I need you to pay attention and then or watch video instead of just reading. Okay, so this is the equivalent resistance. We're pretty good now. Now we are ready to calculate the delay, the TPL, TPHL, and TPLH by using more accurate equation. And it's not too complicated. You only need to know VDD and ID set. Yeah. But what happens if this is the case, right? Here we just draw the, quote the equation one more time. If I keep reducing VDD, you see the R equivalent is almost constant. As a circuit designer, you tell me, do you want to have a VDD at 2.5 volt or at 1 volt based on this graph? What will you do? Your boss asks you, the other team came up with this graph. Now you're the circuit designer. Should I use 2.5 volt or 1 volt VDD for my product?
2.5 volt.
You want to use 2.5?
Yeah.
Why? Thanks for
because at 2.5, R equivalent is constant.
Okay,
like
good.
after any change in VDD, we don't have any change in resistance.
Oh, very good, right? So that you are answering the question already, but we have different criteria. What my criteria? Your boss tells you that he thinks between 1 and 2.5 are also constant. It's constant enough, although it's not absolute, but he thinks this is good enough. The R equivalent is almost constant. Now, what will you do? Are you going to choose 2.5 or 1 volt in this case?
Then 1 volt.
Why?
Because we want smaller VDD.
Why we want small VDD? What's the benefit of doing smaller VDD?
Low power consumption.
Yeah.
Yes. Just by the power consumption perspective, this is good. Some of you can argue, no, lower VDD, I have more noise, less immunity, right? That is also valid, right? So there's no absolute answer, right? But just looking at this curve, I will choose a lower VDD because remember, power is proportional to VDD squared. By reducing from 2.5 to 1 volt or 1.5, you actually reduce the power by 4 times. Your iPhone only need to charge every 4 days instead of every day. That is a big deal, okay? So this goes back to what I've been saying. Power, area, cost, right? PPAC, power, performance, area, and cost. When equivalent, our equivalent is the same. It means the performance is constant for this particular performance, which is the delay, right? It's same. But by lowering the VDD, I reduce the power. And definitely I'm going to do this. Of course, there are too many things to think about, okay? But when your VDD is close to VTH, then the R equivalent depends strongly on VDD, right? That is just because of the ID set if you expand it. Then you don't want to, right? Not desire. And that is what the lady just answered at the very beginning. Too much variation, right? Yes, maybe half of my iPhone is working great, but half of them is so slow that it cannot meet the target. Okay, so nothing new, not rocket science, but I hope you can start having this mindset when you deal with this problem. Think about the right term: variation, power consumption, area, and also the performance. Right? That is the right way to answer the question in your interview if you are in this area. Okay, any questions?